Welcome, Dave Ritzko, Transtar Industries, and today's topic, ceiling rings. Again, I just want to go through some basic types, some new changes that are happening, and why one of the complaints I hear is these rings don't seal. Again, let's just go back a little bit. Anybody kind of remembers a Toyota kit, and I don't even know who made it, and this was back in the late 70s, early 80s. Their butt cut rings that were Teflon were inconsistent at best, and that taught a lot of old timers to watch your rings. Maybe new people don't understand so much. Maybe us old timers forgot a little bit. So let's just do a little quick refresher course. Again, there is many types of rings. There's locking rings, metal. There's types like this that goes on the servo and such, butt cut, and in other words, they just squeeze together. We have scarf cut rings, and they could be big and small. They can have a long scarf cut, they can have a short scarf cut. So why did they kind of get away from butt cut and scarf cut? If you get bore wear, a butt cut ring will keep opening. It gives you gap, creates leakage. If you have a scarf cut ring, as it wears, it's still overlapped by the scarf cut. You don't lose the leakage. You see black iron rings. Then you'll have these seal-plated rings. This happens to be for an AOD 4R70W output. When they used black iron rings way back in the day, absolutely destroyed the case or the bore. The seal-plated rings, Chrysler's use them, Ford uses them, others use them, is a little more user-friendly to the aluminum bore. Again, when you start talking about rings and things that have happened over the years, for T60, for example, a rotational ring on the second clutch housing. It didn't seal so well, and you would have intermittent problems. They went to a non-rotational ring, and I'll show you one of these in a second. So you fast forward to a 6-speed 62 TE, you think they'd have learned their lesson. Not quite so, because on this drum, and everybody that sees them, this ring, how a ring works, when oil energizes it, it seals to the bore. It then spins with the housing. It sticks to the housing. Therefore, this ring is spinning in this ringland. And if you've seen these, it will literally machine that part off. What was their fix? Non-rotational rings. Let's stick a tab on it. It don't turn, can't cut the housing. Great concept. The 6-speed 6L80 series. Same thing when they first came out. Rotational rings. Again, intermittent problems. Some it would affect, some didn't. You get a lot of mileage, but you touch it now, it don't work. So what did they end up doing? Cutting notches into the ringland, made it a little deeper. They added an O-ring, aka expander, and then on the ring itself, it has these tabs, non-rotational. Again, how soon we forget some of the mistakes in the past, and we come forward, and now we have to go back to the drawing board. One thing you should always do, and again, if you've been bitten back in the day by a few the Toyota units, you will know, bore check your rings. In other words, you take the sealing ring, the bore it goes into, you put the ring in there and you expand it with your fingers. And what you're looking for is how big a gap you have. Again, this scarf cut is way more forgiving than this type, because when you put it in, it should collapse, but you should still have a gap because you don't want it to be solid. Now you forced it apart on you, created another issue. The rings today versus the rings yesterday, night and day, way more quality. Guys take their rings because this ring don't seal, I don't like that ring, this and that. Guys, the color on these rings means something. They could be graphite filled, they could be glass filled. Ford had issues for a long time on the center support. They put black iron rings in there. What'd they end up doing? Viton rubber, because it would eat the bore and the housing. So again, guys, if you're going to start using rings in an application that it wasn't meant to be, in other words, you took an oversized ring, you chopped it with a razor blade to make a butt cut, or you cut it long ways to make you a scarf cut, make sure the material you're using is going to work with the housing or the ceiling ring land you're using it on. You can absolutely create your own nightmare. One of the rings that comes up quite a bit, and it's tapered off since, this is out of an RE5 RO5A. The complaint, I put new rings on, the new rings are junk. Not necessarily so. There's two manufacturers for this particular ring. And one thing that I want to show, when you get these plastic rings, they're pretty user-friendly. They have different kind of joints. But when you put these on, these things are not meant to be opened great big. You can actually cause a stress crack back here. Necessarily don't fall apart in your hands, but you have now made the ring untrue. Some of these rings will have scallops, some will not. What are the scallops there for? To help get oil up behind the ring to make it expand quicker. There's some really neat ideas coming out. But one of the main reasons why you have trouble with the RE5 and others, if I leave the old rings on, it works perfect. If I change them, I have an issue. What is happening? I'll tell you what's happening. That ring spins in these ring lands. And I'm using this one because it's a bigger ring land. These things are 90-degree perfect cut. As the ring is energized, it's no longer at the bottom of the ring land. Now it's spinning up from that. What in essence happens is this is no longer square. It actually has either a taper or a ridge at the very bottom. And you can't just look at it with your naked eye and go, oh yeah, I see. So therefore, you put a new ring on, it's not going to seal properly. Now, if you keep running it, ring will wear into it. Eventually, at some point, it'll work. You're not going to be able to give the car away. So why does leaving the old ring on? Because that ring is now mated to that ring land. And by the way, if you're going to reuse your rings, do not take them off and shuffle them. Because now if this ring was on here and you put it back this way, you've created the same nightmare as if you used a new ring. Now, back in the old days, people with machines could go down and what I call a point file. It's a real thin square file. You can go down and clean the ring land. Caution on that is, when you put that file in, you make sure it is straight. Because if you got any kind of tilt to it, you've just taken a pretty decent ring land and destroyed it. Again, these rings are getting fancier and fancier. And one thing I want to show you is a couple new rings coming out. There's Torlon, there's Peak, there's Vespel. This happens to be a newer one. And what we have here is a finger joint. And it's two pieces with the piece going into it. And why, again, are they doing that? So they can seal and have a tolerance level versus a zero tolerance level. Another material coming out is the Torlon, and what they're doing is just lap joints. It's kind of like a scarf cut, but I imagine scarf cutting this plastic is a little different, so it's just a lap joint. Again, got tabs on it, non-rotational, and they're getting really, really fancy. This is a 3D joint, or also called a double lap joint. And this is pretty intense of a ring. This ring also has little dimples on the inside. And again, this stuff probably doesn't energize and is user-friendly as the good old ones you could take like that. So again, they got them so they don't seal at the bottom of the ringland. Oil gets behind them, they will expand and energize faster. Again, guys, it's not always the ring. The rings have gotten way better than the old days. So a lot of times, think about the move you're making. Look real close. If you're going to reuse old rings, I recommend do not remove them from the shaft. My name's Dave Ritzko. Thanks for watching. And as always, you can contact Transtar at transtar1.com. Visit us at transcend.us, or as always, contact your local sales rep.